Okay, two properly insulated uniform rods D and E make thermal contact at one end as shown in the figure 12.7. The cross-sectional areas of both rods are the same. Okay, same cross-sectional area, and the rods are in steady state condition. Okay, this is very important. Determine the temperature gradient along rod D. Okay, and then the temperature T at the free end of rod E, and then sketch a label a graph to show the variation of temperature versus with distance. Okay, temperature versus distance along D and E. Okay, good. So we need to look for keywords, yeah, in this question. First of all, he did mention that okay, two properly insulated, well insulated. You see, he said two properly insulated, and then properly insulated rods can achieve steady state. This is two very important thing. Okay, because once we know these rods are properly insulated and can achieve a steady state, okay, because we know that only the well insulated rod can achieve steady state. When can achieve steady state means no heat loss. Okay, no heat loss. So the rate of flow of heat at one rod will be equal to the rate of heat flow at another rod. So if well insulated, that means can achieve steady state. So that means the rate of heat flow is the same for both rods. This is very important thing. Okay. So one, you must look for this keyword, well insulated, steady state. Yeah. So one thing we know from here is well insulated. So if well insulated, that means can achieve or we can say well insulated means no heat loss. No heat loss means can achieve steady state. Yeah, can achieve steady state. So when no heat loss can achieve steady state, that means this is the most important thing. The rate of heat flow for both rods. That means the dq over dtt for rod D is the same as rate of heat flow for the other rod. Because all the heat that flow from, all the heat that flow from rod, all the rod that flow from rod D will enter rod E. There's no heat loss at all. There's no heat loss at all. Okay, the heat loss doesn't exist. All the heat flow from D will enter E. So the rate of heat flow in D will be equal to rate of heat flow in E. This is the most important thing you should know first. Okay, let's highlight it. Okay, so another thing is he said that the cross-sectional area for both rods are the same. So that means the cross-sectional area AD will be equal to cross-sectional area in E. And then we want to find what? We want to find temperature gradient. Temperature gradient is actually dT over D, not dT over dx. We need to find this. Okay, and then question 2 is want to find temperature at n, the temperature, yeah, the temperature at NE, yeah. So which is this temperature. Okay, so let us do the A1. First we do the A1. Okay, so question A1. Okay, so he already said this well insulated, can achieve steady state. Okay, that means we use this one. Yeah, rate of heat flow in part D equal to rate of heat flow in part E. Okay, so write that down. dq over dt for part D is equal to the rate of heat flow for rod E, because no heat loss. Yeah. Okay, so we want to find temperature gradient. So the temperature gradient for rod D. Yeah, we want to find temperature gradient for rod D. So okay, so what's the formula for rate of heat flow? Rate of heat flow is actually negative Ka dt dx. That is the formula for rate of heat flow. So okay. Okay, so write the formula down over there. Negative Ka dt dx. This is all for D, and then negative Ka dt dx. This is all for E. Okay, rod E. So they have the same cross-sectional area. Same cross-sectional area, so that means the area is being cancelled. The negative sign also being cancelled. And then they have different thermal conductivity because different rods, isn't it? Different rods. So okay, this Kd, the thermal conductivity for rod D is K. Just write that as K. Okay, we have K for rod D, and then for rod E, for rod KE, we have 2/3K. 2/3K. So just substitute 2/3K over here. Okay, what's next? Now, what is the dt for what is the change of temperature in rod D? So look at change of temperature in rod D. Remember, change of temperature is always final minus initial. So for here, for rod E also the same, final minus initial. So you need to determine which one is initial temperature, which one is final temperature, and always use final minus initial. Same goes to rod E. We must also use final minus initial. Don't you do that, final minus initial for rod D, and then for rod E you just change to initial minus final. That's wrong. Must always follow the sequence, final minus initial, final minus initial. Okay, so look at rod D. Which one is final temperature, which one is initial temperature? And normally remember that it's always the final is always the cold one. It's always the cold. Initial is always the hot. Okay, initial is always the hot because heat flow from hot to cold. Heat always flow from hot to cold. So we can say the initial always is the hot, the final is always the cold one. Yeah, because heat always flow from hot to cold. Okay. So look at here. So heat flow in this direction from 100 degrees Celsius flow to 80 degrees Celsius. Always remember, heat always flow from just remember this simple thing. Heat always flow from hot to cold. Heat always flow from hot to cold. So okay, so this hot is initial, cold is final. Okay, cold is final. So heat always flow from up. Heat, just remember, yeah, heat always flow from hot to cold. So comparing between 100 and 80, of course 100 is hot, 80 is cold. 80 is cold. So we can say this is the initial temperature and this is the final temperature. And then for rod E, we know definitely because the heat only flow in one direction, the net heat flow. So of course the heat flow from 80 to T. T is the cold temperature. Okay, so for rod E, 80 is back to initial and T is the final. Remember this, yeah? Heat flow from 100 to 80, 80 to T. 80 is a cold temperature compared to 80. Yeah, actually T is the coldest coldest temperature. Yeah. Okay, so once you knew that, now substitute the value. Okay, so look at the delta T. So delta T is final minus initial. Final is the cold one. Cold minus hot lah. Final minus initial. Yeah. So it's 80 minus 100. The sequence is important. Yeah. Must always use final minus initial. And then delta x. This one is in C centimeter. This one you need to change to meter. Maintain is SI unit. Yeah, change to meter. Yeah, put in SI unit. Okay. But for the degree Celsius, no need to change to SI unit. Yeah, even though degree Celsius is not degree SI unit, Kelvin is a SI unit. But we know that change of temperature, the delta T. One thing we know about the delta T, which is the change of temperature. We know that 1 degree Celsius, the change of 1 degree Celsius is equivalent to change of 1 Kelvin. Okay. So for change of temperature, you can maintain either in degree Celsius or you can change to Kelvin. Yeah, both unit accepted. So you not necessarily have to change the 100 degrees Celsius and 80 degrees Celsius. You no need to plus 273 to get the Kelvin. No need, because the change of 1 degree Celsius is the same as the change of 1 Kelvin. Or we can say the rise of 1 degree Celsius is the same as the rise of 1 Kelvin. Okay, understand? So this one you can still maintain as degree Celsius. Yeah, no need to change. Only the later chapters, when you learn about the Charles law, Boyle's law, like you learn about the Boyle's law, P1V, the Charles law, yeah, the Charles law, the gas law, like P1 over T1 equal to P2 over T2. This one you definitely have to change to SI unit. Yeah, these two temperature need to be in Kelvin. This one, the degree Celsius, not accepted. This one, degree Celsius, not accepted. Same goes to this formula, PV equal to nRT. This one also only Kelvin. You must change to, from degree Celsius, change to Kelvin. Or the temperature. Understand? Because this one is only one single temperature. You have to use Kelvin. You cannot use degree Celsius. But for change of temperature for this question, like this formula dq over dt, negative ka dt dx, this change of temperature here, you can maintain as degree Celsius or Kelvin. Both unit accepted. Okay, good. So now back to this question. So for rod D, what is the length? Yeah, the distance traveled. It is 20 centimeter, change to meter, divide by 100. It is 0.2 meter. Okay. And then for this part, yeah, for rod E, what is the final temperature? T. It is T. And then what is the initial temperature? 80. Okay. And then what is the length traveled? 40 centimeter. So it's 0.4 divided by 100, change to meter. Yeah, 0.4 meter. Okay. Now, so now you can find the temperature here. So let's simplify it and solve it. Yeah. Okay, I got this step. Okay. So the final temperature I calculated, I get negative 295. Okay, negative wait. Negative 295. Negative 295 degrees Celsius. Okay, sorry, I got it wrong. It's not this answer. So the actual answer is 20, positive 20 degrees Celsius. That's the correct answer. Yeah, 20 degrees Celsius. Okay. Okay. Actually, this is more to question 2. Yeah, I have done the question 2. Question 2, question 1, not yet. Yeah, I straight away jump to question 2 already. So sorry, this is actually for question 2 lah. This is for question 2. Yeah, to find the temperature at the free end. The temperature here. Yeah, so at the free end. So this is the answer I get. Positive 20 degrees Celsius. Okay, that's correct. Now, how about question 1? Okay, I'm so sorry. So make it a little. I just want to change the place here. All right, let's do the question 1. Yeah, question 1. Now, we want to find for question A1. We want to find the temperature gradient. Temperature gradient is for along rod D. So it is dt over dx for rod D. Okay, for rod D. Okay, this is for question 1. A1. Yeah. So the temperature gradient along rod D. Okay, along rod D, that's the temperature gradient. So you just use, remember, it is the change of temperature is always the final minus initial. Final minus initial, and then divide by the change of length. So final is always the cold. Initial is always the hot one. So it's hot, it's cold minus hot. Okay, so cold is 80, hot is 100. Cold is so so the change of length is 20 centimeter. Yeah, 20 centimeter change to meter. That means divide by 100, you get 0.2 meter. Yeah, and then the here the change of temperature here is still maintained as degrees Celsius, isn't it? You didn't change to Kelvin. Yeah, never mind, because change of temperature can either degrees Celsius or Kelvin. Okay, so what do you get for this one? Okay, let's calculate 80 minus 100 and then divide by 0.2. The answer is negative. Negative 100. Negative 100. Okay, so what's the unit? Just look at the unit. You put here degree Celsius per meter. Degree Celsius per meter. That's a unit. Or the unit can also be Kelvin per meter. Yeah, because this one can have 2 units. Yeah, can also put as negative 100 Kelvin per meter. Yeah, or degree Celsius per meter. Okay, notice the answer. Okay, is the answer correct? Yes, negative 100 degrees Celsius per meter. That's correct. Okay, notice there is a negative sign for the gradient, temperature gradient. Okay, for the temperature gradient, it has a negative sign. It means that the gradient is negative. The gradient, if you draw a graph of temperature versus, which is the graph we're going to draw later on. Okay, you get a negative gradient. The gradient is negative. You get a negative gradient. So the gradient is actually the gradient of this temperature versus distance graph, temperature versus distance graph, or dt over dx. You get a negative gradient. Okay, because why? Because it's hot minus cold. Yeah, hot is from hot to cold. Because it is dropping from 100 degrees Celsius go to 80 degrees Celsius. From 100 drop to 80, yeah, initial to final, yeah, hot to cold. So that's why the gradient become negative. So you calculate the temperature gradient, you should get a negative value. If you get a positive value, then it's wrong. Okay, also because cold minus hot, a lower temperature minus a higher temperature, surely you'll get a negative value. Okay. Okay, so we have solved for part A, 1 and 2. We got the answer already. So part B. Let's do part B now. We need to sketch a graph. Yeah, we need to sketch a we need to sketch a temperature against distance, variation of temperature against distance. That means we need to draw a graph of temperature versus distance graph. We need to sketch and label. We need to sketch, not only sketch, we need to label also. If you don't label, you just draw the shape without label the value, without label the units, the symbol, you lose marks. Like this one, you need to put the unit also, degrees Celsius and meter. You need to label the unit, the symbol, the values as x also. Okay, now let us draw. But we need to draw for rod D and E, both. So let's draw it out. Okay, now draw it out. Okay. Now we need to label. Okay, this is the axis. We need to label what graph is it? Temperature against distance graph. Temperature against distance graph. So you need to label all this. This is the temperature against distance. The unit also, you are using degrees Celsius. This one, distance, you put meter. You need to write the unit also. Don't forget the unit. And the value, label the value on the axis. So it start from what? Start from 100, go to 80. And then 80 go to, what's the final temperature? The final temperature is 20. 20. So it's 100 go to 80, go to 20. This is I got this one is 20 degrees Celsius. 20 degrees Celsius. T is 20 degrees Celsius. So label that. Label that. So it go from 100 degrees Celsius go to 80 degrees Celsius, and then go to 20 degrees Celsius. Label that. And then the distance is 20 cm, 0.2 meter and 0.4 meter. So this one, rod E is longer. You need to draw rod E longer, rod D shorter. This one is, the E is twice the length of rod D. So you need to draw longer lah. Draw it longer. So this one is okay, I put four boxes for draw 4 boxes for rod D. Okay, 4 boxes for rod D, which is 20 cm. So I change to meter already. So this is 0.2 meter. But for rod E, I need to make longer. Rod E longer, 40 cm. So it's twice the length. So for rod D, I put as 4 boxes. So rod E should have twice the length. So I put 8 boxes. 4, 8 over here. Which is over here. This is 0.4. Wait. Not 0.4. The total length, you need to total up. You see that? You need 40 plus 20. So it's 60 cm. Already the total length is 60 cm. So if you put 0.4, it's wrong. If you put 0.4, it's wrong. It's wrong. So you should put as this one should be 0.6. 0.6. Okay. Because we know, what do we know? We know that this one is 20 centimeter. from here to here, it is 40 centimeter. Change to meter already. So this one is not 0.4. This one is not 0.4. You should change to 0.6. Be careful with the trick. 20 centimeter. This one is 40 centimeter. So this one is 0.2 plus 0.4. So it's 0.6. This one is 0.6. Yeah. Right. Properly. This one should be 0.6. Okay. 0.6. Okay. That's good. Okay. So now you can plot. Understand? You can plot because at the moment here initial is 100, and then go to 80 and then go to 20. So you just plot. Yeah. At first it is at first it is at first it is just plot it. At first it is 100, and then go to 0.2 cm. It is over here, which is just plot it here, and then 80, and then go to 20 finally, which is over here. Okay. Actually you should draw how to say you should draw it a little bit bigger gradient. Okay, I want to tell you, you need to be careful with the graph, because okay, let us join the graph. Okay, it looks like it's the gradient is almost the same, but it's a different rod. It's a different rod, so they should have different gradient. So how to determine that? Because yeah, this one I 180 and 20, I didn't divide properly. Yeah, so I should divide properly for this 20, 80 and 100. Okay. Okay, so I divide properly the temperature also. So let's make two boxes for 20 degrees Celsius. Okay, I can say 10, 20. The maximum is 100, isn't it? The maximum is 100. Okay, 100. So I can have 10, 20, 30, 40, 50, 60, 70, 80. 80 is over here, and then 90, 20, 90, 100. This is 100. Okay, because I put 10 degree, yeah, 10 degree for one box, yeah. So 10, 20, 30, 40, 50, 60, 70, 80, 80, 90, 100. Okay, now I can plot. Okay, first is the 100, and then it dropped to over here. It dropped to 80, and then go to here. It dropped to 20. Okay, so let's draw. Yeah, so now we can draw the graph. Okay, we can draw the graph. Yep, over here, and then like this. Okay. So this is the graph. Okay, this is the graph. Yeah. Yeah. So you can see what you can see is okay, we need to compare, yeah, the gradient. Which one is it logical? The graph. Okay, if you look at here, the thermal conductivity for rod D is smaller. No, it's bigger compared to thermal conductivity of rod E. So this is K. This is only 2 over 3K. So let's do some comparison here. Okay, first of all, we know that the thermal conductivity for rod D is bigger than thermal conductivity of rod E, because the thermal conductivity for rod D is a K, but the thermal conductivity for rod E is only 2/3 K. So we can say this one, yeah, this one is higher, and this one is lower. And then back to the formula we have for the dq/dt, because steady state dq/dt for, you know, this one, maybe I just copy this formula again, and never mind. The rate of heat, because steady state, the rate of heat flow in rod D is equal to rate of heat flow in rod E. Okay, and then write the formula again, negative Ka dt/dx, negative Ka dt/dx. Okay, this is for D and this is for E. So we notice that the thermal conductivity for rod D is higher. This one is higher, and thermal conductivity for rod E is lower, because it's only two-thirds of K. This one is K, this one is two-thirds of K. So this one Ke this is two-thirds of K only. So this is lower. So what happened is the temperature gradient for rod D should be lower. When this one K higher, temperature gradient lower. But for rod E, the thermal conductivity lower, temperature gradient should be higher. Then they will be equal. Then only they will be equal. Understand or not? One higher, one must be lower. One lower, one must be higher. So then only they'll become equal. Only the rate of heat flow is equal. Only the rate of heat flow is equal. So we can say what happened is this one lah. This what happened? Yeah, this what happened. So so this will happen when the rod D has higher thermal conductivity. Then the dt/dx, for the temperature gradient for rod D should be lower compared to temperature gradient for rod E. Yeah, should be lower. This one should be lower. This temperature gradient for rod E should be higher. So is that correct with our assumption? Yes, you see that the temperature gradient for rod D, this is actually rod D. This is actually for rod D. This is actually for rod E. So you can see the rod E is steeper, higher gradient. For the temperature gradient for rod D is lower gradient. So we can say like that. Yeah. This one, the this K is the K is higher, but never mind. Okay. So what can we say is you see the gradient here? Yeah, the gradient. So the dt/dx. Okay. So this is the D again, yeah. So the dt/dx. So the dt/dx for rod D, the temperature gradient is this one is lower, yeah. And then this one, the dt/dx for rod E is higher. Is correct with our assumption. Okay. Yeah, the gradient is lower because it has higher thermal conductivity. The temperature gradient of rod E is higher. You see the graph is steeper. It has higher gradient because it has lower thermal conductivity. See, lower gradient, less steep, smaller gradient. This one is more steep, higher gradient. That's all for. Okay. So you have label the axis, label the unit, also, label the value. You must label the value and also divide accordingly. Yeah, the boxes according to the value. And this one, remember, this is not 0.4, this is 0.6. So there are many things to remember in these questions. Okay, so I hope you understand totally. Okay, that's all for this question. Bye.